right, hello everyone. Thank you for having me. My name is Jannis. I'll be talking about Kubernetes at Zalando and the way we currently run close to 100 Kubernetes clusters in production and test, and how we manage them with a small team. So, who of you has heard of Zalando? All right, that's pretty good. As far as I know, you're not able to order from it in Portugal. Is that correct? Or yeah, not yet. Okay, I hope that changes soon. So to give you a few numbers, you can see them up here. The more important ones are that we have a lot of people working in tech, and I'll share some additional numbers on that one. Since this is the only slide I'm going to do on the actual company, we also have a Lisbon office, and we're also hiring here. So visit our job site if you're interested in actually being able to use Kubernetes and solve problems at scale. Just a quick overview of the talk. I'm gonna give you a quick view of what we do with Kubernetes at Zalando. I'm gonna go into details of some of the architecture choices that we made, and then I'm gonna talk a lot about open source and things we ourselves use in terms of open source software, but also give back to the community. To understand why we actually need that many clusters, or maybe we don't, but that's up for discussion. We have around 2,000 employees in tech and more than 200 delivery teams. One of the reasons of that is that we work in a way where we have teams that are autonomous and responsible for the products or part of the products that they build from like inception to actual delivery. That also means being responsible for running everything from development to production and being on call for the products. To give you a little bit of an impression about the scale that we run in, we run close to 380, I think they're a little bit less now, AWS accounts and 99 clusters. And yeah, we already had the joke about 99 clusters. So below, you can also see a quick run through how many worker nodes we have in total, how many teams currently run, and how many applications, how many pods that is. That's just a snapshot right now. To understand why that even makes sense, it's good to go a little bit into the history of why we use, for instance, AWS. AWS was introduced for us, and the question was here earlier, so teams can actually be responsible for everything they build and then run it in production. And one of the ways to do that and to make them move faster, at least initially, was that every team initially in Zalando was able to have their own AWS account and own everything in it. We, as an infrastructure team, only built a tool set around AWS to make it easier to run, to manage all the account access, ownership, all IAM, to run predefined AMIs. But basically, you had power user access through production, and you build it, you run everything. Starting with a couple of changes, also from an organizational point of view, we are now moving away from the tool set around AWS and actually providing more of a product. And the previous speaker already talked about it, like have a product for the developer based on Kubernetes. The instances and the clusters themselves are not managed by the teams, but the applications still are. It's an hands-off approach for us, meaning that everything that we need to do in our clusters should be done automatically or via central tooling. We do, however, have the ability to go into the clusters themselves and check for irregularities, let's call it that. Maybe to give you a current view on what our status is in terms of adoption. We considered it GA, meaning feature pair to what we delivered to the teams in terms of feature set. That means also being able to easily deploy to Kubernetes and not having to mess around with the actual tooling from a CLI perspective all on their own. They can still do that, but everything in production is only managed by our continuous delivery platform. We have something called a tech radar, where we assess and evaluate different technologies. So Kubernetes for us is in the adopt phase. You can take a look at it. It's pretty useful also, and it's open source. For you, may be interesting. We have critical services running on Kubernetes. So if you log into Zalando from anywhere in Europe, I didn't really say what we do for the people who didn't know what we do, so that was pretty bad. So we Europe's leading fashion platform, and we sell a lot of clothes and shoes and beauty. Sorry for that. So if you log into Zalando from anywhere in Europe, you run on our infrastructure. And for instance, the login service is one component, and then you have the different customer facing, but also internal tooling owned by different teams. And what we want to do in the future is have the Kubernetes system as a default deployment target and an actual sunset date for the infrastructure that we call stubs. So this is like a visualization of developers being able to access Kubernetes clusters. Since I didn't mention this explicitly, we now went from a team perspective to more of a product perspective, and there are several teams working in a community on a different, like on a sub-product, if you will. We have a lot of developers already having access to Kubernetes if they want to use it. They are currently not being forced to use it. We want to sell it. We want to sell them the promise of having a very streamlined, easy to use development and deployment workflow, and obviously give them more time to spend actually developing applications for the customer instead of worrying about the infrastructure. This is a slightly outdated graph of the deployments that we do to various parts of our system. So you can see the CDP part is just continuous deployment platform or continuous delivery platform, and its target is only Kubernetes and AWS only as, let's call it, auxiliary services. So if you want to use AWS specific services like RDS or S3, you can still use our internal tooling to provision it, but the whole compute part is only Kubernetes. And then we have what we're trying to put into the legacy mode AWS stubs, and then there's some parts up there that still run in the data center. So looking at the time, I'm going to spend a couple of minutes talking about the architecture and the changes or the decisions that we made. So first of all, we had to make a decision in the beginning to either have a big cluster for all of Zalando or to have the complete opposite approach that we had before, where we had basically small accounts for each and every team, and that would be 200 plus accounts, probably more like 400 if you count staging. And so we met somewhere in the middle to remain flexible, but also have the ability to actually scale. We're currently still thinking that is the right approach for us, but we're not necessarily sure it will stay that way in the future. It allows us to tune the clusters to the different teams' needs, while also having a certain efficiency of scale. We keep on upgrading Kubernetes to the latest stable version. We normally have about the time when you see it in GKE at Google going into developer preview. We also run the latest version in our development environments. We run our cluster upgrades continuously and non-disruptive to the customer. More on that later. And we want to have fully automated operations. So our team, which currently is 9 people, only manages the whole update of the clusters using Git. So maybe a little bit of more detail on the cluster setup. Don't mind that you see a lot of technologies that you might not use. That's not the point. It's to give you an overview of what we actually take as like the core components. The orchestration part is based on CloudFormation. We run, and that's still one of the reasons is back in the history where it was best supported, CoreOS as our distribution. We run all our clusters in a multi-AZ setup for workers, and for the production clusters, the control plane is behind ELBs and highly available. All the cluster configuration is stored in Git, so any changes that we make can be reviewed and, if necessary, rolled back. So maybe for the more interesting part for you, also if you wanna, this doesn't really matter if you run 100 or 3 clusters. We run end-to-end tests when we want to update or upgrade our clusters. It has proven very useful to do so. And then we have something that you only need if you actually have a lot of clusters for your customers, called a Cluster Lifecycle Manager, and I'll go into detail a little bit more. When we have users actually wanting a cluster, we don't have to go ahead and create our own AWS account and run any scripts against it. We basically just have something called our cluster registry, create a new entry in the cluster registry, and the rest is a tool that we call the Cluster Lifecycle Manager that manages the lifecycle of clusters from the birth and inception through the update and upgrade phases, but also if we want to retire a cluster. You can check it out in terms of code because it's all open source. Most of the things in the CLM don't necessarily make sense if you don't run additional components. So this is more of an, let's call it, inspiration for others to look at our best practices, and also for us to get feedback on maybe things that we can improve. Basically what the Cluster Lifecycle Manager does, it talks to both the AWS API for provisioning CloudFormation resources, as well as to the Kubernetes server after the bootstrapping process to run updates. So an example with that would be if we would like to introduce a new feature in the cluster. We would create a team, just developers like the teams that are our customers, would create a feature branch, do a PR, and add a so-called ready-to-test label, and that would trigger our end-to-end tests. I'll spend some more time on the next slide to talk about the end-to-end tests and why they are important. Basically, if everything succeeds, we can merge it to our development branch. Then we can observe if the actual system behaves as we expect it to, and then we do a manual PR to alpha branch, beta branch, and eventually a stable branch. This only makes sense if you look at what we call channels. So I don't see my comments here right now, so I'm trying to improvise from to explain it best as I can. A channel for us is, you can see it as a release candidate for the next channel in lines. Other software projects also have that. For instance, CoreOS uses development alpha and beta channels. And basically, what we want to achieve is when we merge to a certain branch, we have time to test that branch in a certain environment. For a dev channel, it's our own development cluster and a so-called playground cluster, which gets destroyed and recreated every week. Then we have our main infrastructure cluster, which we run in our alpha branch. So this is actually production for us, so we care about it, so we better make sure that it works. This is, for instance, also running the main instance of the cluster lifecycle manager. And then we have our product clusters, so all our customers run their test and production clusters on the beta channel. We didn't go into stable yet, not because we don't consider it stable, but there was no need to have yet another channel. So we run end-to-end tests on every PR. I would normally go into GitHub, but you can also check it out if you go to the link and look at our PRs and the tests that we run. You will not be able to see the details because they're on our private Jenkins, but if we take a look at what we run in terms of test, we run the upstream conformance tests. We run something specific to, in this case, AWS in terms of stateful features. So we test if, for instance, the EBS volumes are attached correctly, and if an application can run a stateful set, so a stateful application with this release. And we have custom Zalando tests. Try to extract some of the tests from the Jenkins to give you an idea what we do. You don't need to go into the details. So the upper part is all the it's part of the end-to-end tests that are part of the conformance suite of upstream Kubernetes. So you can also see different SIGs associated to different tests. And then we have things like testing external DNS creation, because external DNS we use also, and it was open sourced by us and we still maintain it. If we want to update our infrastructure, and I'll try to speed it up a little bit, to run the end-to-end test, we found it best to create a cluster from the actual base branch, so the as-is stage, then update the cluster, because we had actually problems in the past where the actual update process would fail. Then when we run the end-to-end tests and see if everything is working for us, and then we throw away the cluster. This is done every time you add the ready to test label to GitHub. So to sum it up, we have one production cluster per AWS account and one per product, or rather two per product if you count a test cluster. We normally only have read-only access to production for our developers, but you can get emergency manual access. That also means all the write access to production is done via CI/CD, and maybe also important, but I also already mentioned that we run multi-AZ clusters. So I was going to talk a little bit about lessons learned, but I think I'm running into time travel. No, I'm still okay? Good. So maybe we should turn that around, because the non-technical stuff is maybe more important, but there's a lot of technical things that we learned, and I will probably try to link, because it's not online yet, a talk by my colleague Henning during Container Camp UK earlier this month on 1 million ways to crash your cluster. So you can take a look at how many incidents we had in production. But a lot of the things that we learned out of it, like backup your data, backup your etcd, make sure you monitor your backup and like actually test it. Be careful using T instances in production. So if you run on AWS and maybe you have someone to talk to, and maybe ask them if it's a good idea to run T in production, we found you have to be careful, so we're not doing that anymore. And one thing that we introduced quite recently is that we disabled CPU throttling, so it's called CFS quota in all our clusters, to avoid latency issues that we ran into. If you want to know details about this, I'll be happy to chat about it. Maybe from a more non-technical perspective, which was also mentioned in the previous talk, which is really important, is like try to avoid friction for your users. It should be as easy as possible for them to actually get something running in development and in production eventually, and that you can only achieve if you actually start talking to your users. And that doesn't mean you have to run 100 clusters. This is the same in a small startup, I guess, as in a larger corporation. For a larger corporation, it's also important to create a system compliant by design, so your developers can actually focus on developing and not worrying about the things that they do, maybe breaking something non-technical, I would call it. And it's very important, especially in larger companies, we learned that you create a community. So you have the developers, or anyone actually using the system, talk to each other and helping each other, because we can't be anywhere, everywhere at all times. Plus also a lot of the things that we didn't think of in terms of use cases actually make sense, and then they are brought into the product by the developers, or the customer in this case themselves. So I'm going to not go into detail in the open source projects. I'm just going to mention them, and they're all linked here, but we are trying to put as much as we can that we think is useful on GitHub and give back to the community. So what we use, and we actually were really happy to see it picked up by the Kubernetes incubator. Initially it was only Zalando supporting it, is external DNS that creates and updates all the DNS records, not only for Route 53. I don't know how many providers we now support. I think it's well more than 10. And we also have a custom ingress controller that is open source, which is called Skipper. The question here earlier was also, how do you run databases, or maybe also handle databases in such a setting? We have something called a POSTGRES operator, which is also open source, which basically manages not only the bootstrapping creation, but also the lifecycle of PostgRES inside Kubernetes. We also still run certain services outside of Kubernetes. And you get a whole list of open source projects that we have and that you can take a look at and hopefully learn something from and contribute, obviously, because we're very reliant on the community also to give us new ideas and help us improve on our product internally. That's it for me. Thank you. Any questions?
You sell clothes. Zalando sells clothes. And what more for having 2,000 pets?
I think I have to just skip back to the initial slide. So yes, we sell clothes. We started with flip-flops, and we went into shoes, and now we have over 300,000 different items in our lineup of so clothes. All the big brands are on Zalando. Shoes still, and we just got into beauty. We're still focusing only on Europe so far, but you have to imagine that we not only actually run the shop, but run the whole logistics behind it. That's also why we have 15,000 employees and only 2,000 working in tech. And all the software that runs our logistics is also written internally. So only a fraction, well, not only a fraction, I don't know the exact numbers, but a lot of the teams are not working on software that is touching you as the end customer. There's a lot of things behind the scenes for the brands, for them to put things into our system, for procurement, for logistics. So all these things need software, and we think we, our tech company, can do a better way of supporting our internal customers than by using off-the-shelf software in most cases. There was one more.
You mentioned that you use multi-AZ, so I've been so I think that it is multi-data center. By data center I mean locations. Amsterdam, UK, Ireland.
Mm-hmm.
Do you use deployments in different locations or only in the same data center?
Yep. So the question was if we also run multi-region services. We currently don't, because our experience has taught us that the data center in Frankfurt that we run in is pretty stable. We have some teams that have backup capacity in Ireland, and we're looking obviously always of ways to diversify. So we, at least in theory, have the possibility to run Kubernetes on any other cloud, because most of the things that we use, if not all, except maybe for some IAM stuff, can be transferred and run in any kind of vanilla Kubernetes, because we use all the additional services like external DNS, like INGRESS. They're agnostic to the actual infrastructure.
So deploying to US, if you want to go to US, would be quite easy.
Yes, it would. But currently there are no plans to go outside of Europe. There was another question?
With such an amount of applications or service that you have, that were outsourced, how do you manage the overall view of what you have, especially for someone that is onboarding? How do you prevent that you don't have two teams working on the same problem with different names or things like that?
We as an infrastructure team don't really care what you run on. Normally it's managed by the so-called dedicated owners. So there are dedicated owners for a variety of products inside the company, like the fashion store, which is our main shop, or things like our whole IAM infrastructure. So those people who are owning the services and the teams who own the services are responsible for not duplicating effort, I would call it.
Do you have any way of broadcasting what the overall system is about?
Yes, we have an application registry.
Also changes that's happening because you have probably new features adding to the service or new capabilities. How do you manage that documentation flow across everybody?
There are two questions, so maybe the first one first. How do we manage or create transparency on applications? We have a central application registry where you have to register and describe your application before you run it in production, otherwise it won't get deployed. It's called Kio. It's just an internal thing that you can query, but more important thing is that you can actually find out what the component does and who is responsible for it. In terms of creating transparency on what to use when. We put a lot of effort into internal documentation and keep on improving that. So we also run, for instance, for our product, we run our support for the internal developers in our team. So we have, depending on the different teams, we manage to have one person on support duty each day and answering questions, preferably also with our own documentation. Then in addition, chat rooms where you can talk to other users, and that basically proliferates the information on what you actually, if you have a problem, you can't solve it on your own, you can go there.
I'm interested in the history of this. I mean, did one person come in and say, we do Kubernetes, or how did it all start?
We have something called Hack Weeks at Zalando, where different teams and different departments come together and for a whole week just hack something together. And the initial idea actually came from a Hack Week, the initial prototype, to take a look at, does it actually make sense to run Kubernetes for us? And we did not go into GA until, I think, did I put it here? No. Until, I think, May, June this year. So we spent around 1.5 years with pilot customers internally, actually maturing our service and making it what we call feature pair to what we used before. There's still a lot of things that are not necessarily the same as with our tooling beforehand, but we're almost there. For instance, we just introduced more sophisticated traffic switching. And we also have a layer where we have IAM services running in our applications, being able to use sandbox credentials. So those are just 2 examples on what the customer internally expects and what we have to deliver as an infrastructure team. Yes?
I need to ask, so how do you convince management to say, okay, what we have works, but we want to switch to this?
Money. Yeah. So I have to repeat the question. How did we convince management to invest in that kind of infrastructure? It was actually, apart from our genuine belief that we can run more efficiently and effectively and more compliantly on Kubernetes from a central point of view, we were able to convince with a business case the management that if we run all systems from a central perspective, we can be much more cost efficient. And then the second selling point was compliance. So we are able to control the way our systems are operated and also deployed to in a more compliant way. And this is very important for us since we're a publicly traded company and we have external audits, and if an external audit does not go our way, it actually has very real effects on the stock price, so it's money again. So the question is if and how we are doing blue deployments or canary deployments. We do them quite a bit in different ways. One of the main enablements that we have is our INGRESS controller and the way it routes traffic. And we built something on top of it. I don't know if it's linked here. It's called stack set controller. It basically allows you to create a notion of a stack, which is something that we used before, so that's why it's called a stack. Basically an application in a certain version, and you can have multiple stacks at the same time with different percentages of traffic. And what happens is if you create a new stack, it will start with an initial amount of traffic or none, and then you can slowly switch the percentage of traffic to that stack, to that application. And if you see that it fails for some reason, you can roll it back. Or you can even do more extensive tests and run 3 stacks in parallel, or 4, and then only route a certain amount of percentage to like 2 stacks, and the main one still receives the initial, I don't know, 80%.
So after that, you manage how do you switch between
And it's the stack set is an operator on top of Kubernetes, and this one controls the ingress, which then routes to different endpoints in the cluster. You can look at the code on GitHub, so I can link it afterwards. For the user, we make it usable by integrating it into our own deployment workflow. So basically what you do is you write yet another YAML file and define the steps that you want to increase your traffic, and then you can switch between them. So you can start with 10% and then use our deployment platform to either manually or automatically increase the amount of traffic. You can also use our CLI and do it manually only in the test clusters though, or with emergency access in the production clusters. Any more questions?
All your clusters are on the cloud, or do you have a private Kubernetes cluster?
We have an experimental data center cluster for Kubernetes, but it's only for migration purposes.
Why you don't use private and use Kubernetes on the cloud? Is there a technical issue?
Mainly because all our teams are already on AWS and already using a lot of services, and we're in the process of actually getting away from the data center deployments, and also makes us, well, focus on, I would call it, the important things instead of managing our own data center.